For my third project, I created a first-person shooter game set in a sci-fi environment. I focused on developing the material for Flash, generating spider webs in Houdini, building parts of the FPS gameplay blueprint, and rigging and animating an original alien insect character. In this project's current stage, players can pick up weapons, fire into the environment, and generate a bullet hole decals on meshes. Additionally, there are alien spiders performing idle animation as a form of demonstration. At this stage, the spiders cannot be killed because I haven't implemented that animation for the spiders yet. But players can also switch between different weapons. For example, we can swap from a rifle to a pistol. When firing, bullets are generated from the weapon slot using emitters, ejecting them from the chamber. On the technical side, I focused on making the hand animations align with the weapon by editing the socket direction into the skeleton editor. I adjusted the weapon's rotation to a proper angle. I also created a blend animation where the reload and weapon switch animations are played in reverse for a smooth transition effect. To add a realistic effect to the shooting, I also implemented recoil using the transform modify bone node, which displays the hand slightly when firing. The bullet casing effect was achieved using emitters. I opened the skeletal mesh of the weapon, located the socket for the magazine chamber, and linked it to the spawn emitter at the location node. This allows a bullet casing to eject each time the weapon fires. The bullet hole decal was implemented using recasting. If the recast detects a surface that is not a weapon or the player, a decal is applied at the impact point, creating a realistic bullet hole effect. For the UI, a dynamic crosshair appears when the player is holding a weapon. The crosshair dynamically expands or contracts depending on player movement, enhancing the realism of the shooting experience. Finally, I implemented weapon pickups using overlap events. When the player enters or exits a severe collision area, the UI is triggered. The system checks if the object has a player tag. If so, it displays the pickup UI. Players can pick up multiple weapons and store them in an array, allowing switching between weapon slots via key inputs. Another exercise I worked on was rigging an alien spider. Houdini's rigging nodes helped simplify naming conventions and hierarchies, while allowing easy adjustments to joint orientations. The basic skeletal framework, including rough weight painting, was set up in Houdini. Using the joint deform node, I could handle basic bending and repetitive animations directly in Houdini. However, for precise control and animating using controllers, we have to move the workflow to Maya. In Maya, we can differentiate between IK inverse kinematics and FK forward kinematics systems to drive specific parts of the spider. For spider-like creatures, the lower three leg joints and the head's center of gravity are typically driven by IK, while the upper three leg joints, abdomen and back fins, are driven by FK. In Maya, I set up constraints scaling and weight painting for the alien spider. The rig included 3 skeletons, the IK rig, FK rig, and the skin rig. For the legs, we should implement a system to toggle control between IK and FK weights. The spider's back structure, which resembles protective fin shielding its abdomen, used a bend deformer to enable varying degrees of bending at each joint. To achieve a curling effect for the fan-like structure on its back, I adjusted the bend deformer radius to control the curvature. This allowed the fan to open and close naturally. Finally, I created an idle animation like dancing for the spider using controllers. It's important to note that because of the 3 skeleton systems, baking animations directly to the FK and IK rigs would result in some loss of data. Therefore, the animation was baked for the skin rig. After removing all controllers, we can import the spider into Unreal Engine along with its skeleton mesh, rig, and animations. And this is how the final animation looks when imported into Unreal Engine 5.